6.3 is our last section in chapter 6, and it's kind of our last section in this unit. So once again, make sure you feel comfortable with 6.1 and 6.2 before moving on to 6.3. If you need to review those two sections first, make sure you do those assignments because 6.3 is obviously a little bit harder than the previous two. So that being said, let's start with our first example here. Solve cosine 2x is equal to root 3 over 2 for all values between 0 and 360, including 0, not including 360. All right, so there's a couple of things I want us to notice. What makes us different than the previous two sections we've done is that it's a double angle, but there's nothing else with this. There's nothing else to like add or there's nothing else adding or subtracting. Like there's nothing else but this double angle. So for us to change this double angle into something else really like wouldn't help us out all that much. So we're going to leave the double angle as it is, and we're going to deal with this accordingly. So if we like to think, I think a good way to think about this is thinking about 2x as 2 times the unit circle, or if you want to think about it as 2 rotations, okay? And like the problem below it, 3x, we'll think about 3x as like 3 rotations. So keeping that in mind, I'm going to move to our domain super quick here, make a quick note, and then we'll actually solve this, and I'll show you how we do this. So if this is saying x is between 0 and 360, but if I look at my problem and have 2x, I want to multiply both ends of this interval by 2 and see what I get. So 0, 2x, 720. This is going to be the domain I work with, and I'll show you how we do this, all right? So we get this 2x by multiplying both the 0 and this 360 by 2 to get 720. So let's actually solve this problem. And we don't need a whole lot of room for this, but I just want to show you how it's done. All right, so we're going to say cosine 2x is equal to root 3 over 2. It's a weird looking 3. Okay, we're going to inverse this. Okay, so cosine inverse of root 3 over 2 is equal to 2x. Okay, so this 1 is going to be for the first rotation. Okay, so where is cosine equal to root 3 over 2? Where is this inverse going to be true for? This is going to be true in the first quadrant at 30 degrees. And it's going to be true in the fourth quadrant at 330 degrees. Okay, first quadrant 30 degrees, fourth quadrant because cosine is positive in the fourth quadrant, reference angle, however you want to think about it. Those are our two angles here. All right. This 2 stands for our second rotation. All right. So how we get from our first rotation to our second rotation is add 360 to each of these values. So 30 plus 360 is going to be 390. And 330 plus 360 is going to be 690. So all 4 of these angles are equal to 2x. Now I don't want 2x, I want regular x. So my final step here, so I'm just going to rewrite this over here, 300, 330, 390, and then we have 690. My final step here is just to divide everything by 2. Okay, so 30 divided by 2 is 15 degrees. 330 divided by 2, I'm just going to check my math. So 330 divided by 2 will be should be 165. Good. 390 divided by 2. So we have 2, 9. This should be 195. And then 690 divided by 2, that would give me 345. And that's equal to x. So my answer here are these x values, 15, 165, 195, and 345, and you can tell that these answers are in this range, just 0 to 360. This 2x helps us get them, and then we divide by 2 to narrow them down to get them into my original range. Don't worry, we have a lot of these to look at, a lot of these to get through. So if you're not comfortable with it, I promise you, you will be by the end of this.